Okay, so next skill we need to do for integration, next way of integrating is to integrate by substitution. Okay, now the giveaway is in the title. We are going to use a substitution of some description in order to manipulate our integral into something we can integrate far easier. Okay, so a lot of the time in your exam it will tell you what substitution to use, so what value of u it wants you to use, which makes it a bit easier. Sometimes you may have to come up with yourself. So our question is, use this substitution u equals 2x plus 5 to find the integral of x root 2x plus 5 in respect to x. So what we are aiming to do is to get rid of x entirely and swap everything out with u's. That does also include the dx to swap with a du. Okay, so first thing we're going to do is we are told that u equals 2x plus 5. Okay, so what we are going to do is we are going to find du dx. So differentiate with respect to x to give us 2. Now what we've got in our question is we've got lots of x's and we've got a dx. So we need a substitution to swap x out for something in terms of u. So once you've got your initial substitution of u equals something, you want to just rearrange that equation to make it x equals. So x is going to equal u minus 5 over 2. And it's the same with the du dx. We want to make it into dx equals something. So multiply the dx up, take the du down, so we'll get half du. So we now have these two parts. Okay, we now have dx equals a half du and x equals u minus 5 over 2. Okay, and that's what we're going to use. And we're going to substitute those in to our initial expression. So we take our initial expression from here and we are going to substitute in our values of u and du. Okay, so this becomes the integral of x, which we know is u minus 5 over 2. Okay, times by the integral of 2x plus 5, which we now know is u. And rather than dx, we're going to substitute in times by a half du. Okay, we're going to tidy this up a little bit. So we'll have the integral of a half. So we've got a half and a half there, so we're going to end up with a quarter. So this is just a case of tidying it up a bit. Lots of u minus 5, lots of root u du, which in order to integrate, we're just going to expand out and just put into singular powers. So u to the half times u is u to the 3 over 2. So we end up with a quarter lot, so I'm just going to take the quarter out of my integral. U to the 3 over 2, subtract 5u to the half du. Okay, all that is a little bit of manipulation. We can now integrate our expression. So we can take a quarter out, as we did do before. Add to the power, divide by the new power. So we do u to the 5 over 2 over 5 over 2 minus 5u to the 3 over 2 over 3 over 2 plus c. And we're just going to tidy that up a little bit. So we end up with a quarter lots of 2u to the 5 over 2 over 5, subtract 10u to the 3 over 2 over 3 plus c. And we will from there, we can then put our values of x back in. Because we know that u is 2x plus 5, we can sub those values back in again. So we can go to a quarter, lots of 2, lots of 2x plus 5 to the 5 over 2 over 5, minus 10 lots of 2x plus 5 to the 3 over 2 over 3 plus c. Okay. What we will do as well is we can just tidy that up. So we'll take the quarter out. So that would become 2 over 20. So it will become 1 over 10. So we end up with 2x plus 5 to the 5 over 2 over 10. Subtract, becomes 10 over 12. So we'll have 5 lots of 2x plus 5 to the 3 over 2 over 6 plus c. So just a case of tidying it up at the end. But it's all about using that substitution at the top to integrate in terms of u, because we've changed it into du rather than dx. Okay, and then substitute back in at the end. So we put it back in terms of x, and we can work it out from there. Okay. Now, one of the things you do need to be aware of relatively quickly, okay, is the fact that you may sometimes need to know what your substitution is. Okay, so we need to know how to work that out. Now, in most of your exams, okay, you'll be given it. However, especially if some of you want to go on to do maths at university, you may need to come in to yourself. Now, there is no hard and fast rule with it, but normally what we try and do is we try and get rid of expressions that are within square roots or powers or denominators of fractions. So, for example, for cos x root 1 plus sin x, the sensible substitution would be u equals 1 plus sin x. So then we would end up using root u instead. For 6x, lots of e to the x squared, we want to get rid of that power from e. So we will make u equal x squared. For the integral of x e to the x over 1 plus x, we will make it 1 plus x, so it will get rid of the function, the expression of the denominator. And finally, you would make u this time actually equal a fraction itself, because again, far easier to integrate in terms of u when you've got that in rather than the initial part. Okay. But, as I said, for most of this, you will be given, okay, the substitution for you. Okay, right. Let's go through another example. So, you are told to make u equal sin x plus 1. And we've got to find the integral of cos x sin x, lots of 1 plus sin x cubed. Okay, so first step, always the same. We're going to start with u, and we are going to find du dx. So, u equals sin x plus 1. So, du dx, so when I differentiate sine, I become cos. So I just end up with cos x. From there, I can then alter these two into what I want. Now, making x the subject to the first one is really, really difficult. So what I'm actually going to do is I'm just going to leave it as sin x equals u minus 1. It'll be far easier to work with that than work with inverse or arc sine. Okay. Du dx equals cos x. I need to just have what dx equals. So dx will be 1 over cos x du. Okay, so I've now got what x is. Okay, I've now got what dx is. So I substitute back in to my original function. Okay, so this is step 2, just a little bit higher up. So we're going to substitute back in. So the integral, now I've got nothing for cos x at the moment, so I'm just going to leave that as cos x in the hope that that will simplify back out later on. Okay, sin x I know is u minus 1. And then I've got 1 plus sin x, which I know is u cubed. Dx is 1 over cos x du. Now I'm happy because what I've got is I have already up here a cos x. So those two cos x's can cancel each other out. So now I've got everything in terms of u. What I'm going to do is just collect that all together and simplify it. So I end up with, the 1 obviously doesn't do anything. So we end up with u to the power of 4 minus u cubed du. Now suddenly that becomes much, much easier to integrate. Okay, so we're on to step 3 now. So we integrate our function. So we will end up with u to the 5 over 5 minus u to the 4 over 4 plus c, because we're not doing definite integration. Once we're back into that point, we sub back in our value of u, So we will end up with sine x plus 1 to the power of 5 over 5 minus sine x plus 1 to the power of 4 over 4 plus c. Okay, it normally tells us the substitution we want, okay, which definitely helps. Work out what x equals from that substitution, work out what dx is from that substitution. It's not always necessarily x, it's something in terms of x, which then will cancel back out, integrate with respect to u, because you now got du rather than dx, then sub back in again afterwards. Okay, right. Oh. Okay, so little bit harder. So when a root is involved, it makes things much easier if we use u squared instead. Okay, so this is again another version of question 1. It's exactly the same thing. The difference being this time we are told that u squared equals this. Now if you are told to use that substitution, you cannot change that to u equals something. Okay, you have got to work with u squared. Same process though. So if I know that u squared equals 2x plus 5, okay, I'm still going to manipulate this so I have x equals. So it's just going to end up being u squared minus 5 over 2. Now, this is where a bit of implicit differentiation comes in. Okay, because I'm going to differentiate both sides with respect to x. Remember, when we differentiate something like u with respect to x, this is going to become 2u du dx. Okay, implicit differentiation. Then we differentiate the other side, 2x plus 5 will just become 2. Same process still, I want to make sure I've got dx equals something. So, as I manoeuvre this around, I'll have du dx equals 1 over u. Okay, which then means that dx, when I multiply dx up, I can bring u back down, so I will end up with dx equals u du. Okay, because we'll just manoeuvre it around and we can get to the answer we want. Again, we're going to substitute in. From this point onwards, it is very, very similar. Substitute back into the expression. So I now have the integral of x is going to be u squared minus 5 over 2 times by, we now have u squared equals the middle, so I end up with the square root of u squared. Okay, dx we know is u du. We need to tidy this up still. Well, u squared u just becomes u. Okay, so this will become u squared. So we will end up with u to the 4 minus 5u squared over 2 du. Okay, which we will just separate out to make it a bit easier for our integration. So we end up with u to the 4 over 2 minus 5u squared over 2 du. Then we can integrate. So add 1 to the power, divide by the new power. So we end up with u to the 5 over 10 minus 5u to the 3 over 6 plus c. Last step, sub back in our values of x. So we end up with u to the 5. Now this is more difficult because we know that u squared equals 2x plus 5. So therefore u to the 5, okay, will be 2x plus 5 to the 5 over 2 over 10 minus, same with the next one, if u squared is 2x plus 5, u cubed will be 2x plus 5 to the 3 over 2, and that will be over 6 plus c. Okay, now there is very marginal difference between doing it in this form or doing it as we did for the first question. We didn't have to integrate with fractional powers, which does help. However, this one is slightly harder with the substitution at the end. with most of your exam questions at least, you will be told what to substitute into. So you will not have to make that decision yourself. Okay. Other than that, it is relatively simple what we are being asked to do. Okay, right. What I want you to do is you are told the substitution to use. I want you to pause the video and have a go at it. Big hint on the screen already. You might want to use a double angle formula first to get rid of the sine 2x. So use the double angle formula for sine 2x first and then go through the process. So pause the video, have a go at it, then we will have a look at it together afterwards. Okay, so first step I want to do is I'm going to change 2 sine 2x into something a little bit easier to use. So I know that sine 2x equals 2 sine x cos x. Okay, double angle formula. So 2 sine 2x is going to give me 4 sine x cos x. So this is now going to become the integral of 4 sine x cos x, okay, over 1 plus cos x dx. I use my substitution, so I am told that u equals 1 plus cos x. Okay, so I'm going to have cos x equals u minus 1. I'm also going to have du dx equals, well, cos will differentiate to minus sine. Okay, and then I need to make sure I have dx, so that's going to be minus 1 over sine x du. Substitute my two parts in. Okay, so this now becomes the integral of 4 sine x. Okay, I don't have something for sine x yet, so I am just going to leave it as a sine x. Cos x, I know, is u minus 1, over 1 plus cos x, which I know is u. Then I need to sub out my dx, which I now know is minus 1 over sine x du. So again, same with the last one when we did trig functions, we know that that sine x and the sine x before will cancel. Make sure you do not miss your negative one that you have to make sure you take through with you as well. So just going to simplify this out. So I'm going to have a negative 1 and the 4. So I'll end up with minus 4u plus 4. Okay, all over u. I'm going to separate these out into separate fractions. So I end up with minus 4 over u. Okay, and obviously the u's will cancel, so I just have minus 4 plus 4 over u du. I can then integrate that. Okay, so by integrating that with respect to u, so it'll end up being minus 4u, then 4u, 4 over u even, is 4 lots of 1 over u. So this will end up becoming plus 4 log natural u plus c. Last step, sub it back in for our x's. So we end up with minus 4 lots of 1 plus cos x plus 4 log natural 1 plus cos x plus our c. Okay. When we compare that back to the top, I've got to multiply my brackets out quickly. So I'll have minus 4 cos x plus my 4 log natural 1 plus cos x plus my c. So when I match these up, I've got my 4 log natural 1 plus cos x, I've got my minus 4 cos x. Therefore, k will have to equal c take away 4. Okay, it's all about using your substitution. You might have to use a double angle formula in there as well. Use your substitution, get everything in terms of u, so you can differentiate, so that you can then work your way through. Right, only other bit we need to look at very quickly is our definite integration. Works in exactly the same way. Okay, there is just a couple of extra bits you need to be aware of. So, with regards to this, substitution is going to be u equal 1 plus sine x. Okay, we have already seen this one. So, we can have sine x equals u take away 1. And we can have du dx equaling sine differentiates to cos. So, dx is 1 over cos x du. We can substitute both of those in. So we end up with our integral between pi over 2 and 0. Cos x we leave as, times by 1 plus sine x, which is u. Dx is 1 over cos x du. Our cos x's cancel. So we just end up with an integral between pi over 2 and u of u to the half. Okay. Now, what we need to be careful of, our limits originally were in terms of x. Now we're differentiating integrating in terms of u, we need to alter our limits as well. So, when x is pi over 2, all we are going to use our substitution in for u. So u, in this case, will become 1 plus sine of pi over 2, which you will just put straight into your calculator and get your answer out of as 2. And you do the same with the next one. So it'll be 1 plus sine of 0, which is going to give you 1. What you have got to make sure is the limits stay in the order they originally were. You may find that once you substitute these in, the limits don't look correct. Okay, that's absolutely fine, but you've got to keep them in the order they were. So what will end up happening is, the integral I actually have is the integral between the limits of, well, originally it was pi over 2, so it's now 2. Then it was 0 on the bottom, so it's now 1, of u to the half du. Okay. Go back to our square brackets, so it's going to end up being u to the 3 over 2 over 3 over 2, which goes to 2u to the 3 over 2 over 3, between 2 and 1. We substitute in and simplify, and we should end up with 2/3 lots of 2 root 2 minus 1. Okay, obviously make sure you substitute in properly and subtract and simplify. Okay. Big thing with this, make sure you adjust your limits accordingly as well. Right, last one I just want you to pause and have a go at quickly. So can you please pause and have a go at this, and then we will go through it. It is literally just a show that question, guys. You do not need the final answer. Okay, pause, have a go now. It tells you the substitution to use. Okay, so let's have a look. Right, we have got y equals x cubed log natural x squared plus 2. We are told to use the substitution of u equals x squared plus 2. So we need du dx equaling 2x. So dx equals 1 over 2x du. We need to have, in terms of x or x squared, it doesn't matter necessarily. Okay, what we'll do is we'll leave it in terms of x squared to begin with, u minus 2, and we are going to substitute in. So, subbing in, I'm going to end up with the integral of x cubed, okay, which at the moment I'm just going to leave as x cubed, okay, and we'll come back to that in a minute, times by log natural u. Dx we know is 1 over 2x du. Now, the reason I've used that x cubed is because I can see that this is going to simplify a little bit. So this is going to simplify to a half x squared times log natural u du. Okay, and what that now means is I've got a value for x squared. I know that's u minus 2. So this ends up being, I'm going to take the half out as well. So it's going to end up being u minus 2 times by log natural u du. Okay, right, once we've got to that point, okay, it's looking very, very similar to what we've got here. All I need to do is alter my limits. Now, my limits at the very start were between root 2 and 0, because I get those from my x values. So I've got to use my substitution from up here, and this is maybe where I want to take this down, and I want to say that x equals the square root of u minus 2, so take it a step further, so that now when I substitute these in, okay, it might, actually it's not going to be any easier, let's use the original one. So we are going to still use x squared equals u minus 2, and we're going to go through and solve. So when x equaled root 2, root 2 squared is going to be 2, so we end up with 2 subtract 2 to give me a sorry, 2 plus 2 to give us 4. When x equals 0, we're going to have 0 equals u take away 2. So we have u equaling 2. So there are our limits of 4 and 2. Right, can you go on to show my homework for me, please, and attempt the questions that are attached?